Action.
Today, ladies and gentlemen out there in cyber land, we're going to talk about refraction. And refraction is simply when light bends when it passes through another substance. And typically in physics, that other substance is glass. It could be water. It could be anything. But it bends. It literally bends. And just to do a little backtracking, in a plane mirror, which Rachel was looking for, like the plane mirror on the wall there, you do not have refraction. What do you have?
Reflection.
Reflection. You have just reflection. The rays do not bend. Okay, just a little side note there. Okay, cool. Now, there are two kinds of bending, if you will. We have one is called convergent. And as the name suggests, the rays come together or converge. And a lens that is convergent or a mirror that is convergent, the rays will come together and you will get an image. An image will be produced on a screen. You can actually see it. Okay? In a convergent lens or mirror. You get a real image because the rays come together. A convergent lens is convex, or double convex. It is shaped like this. A convergent mirror is just the opposite. It's concave. It looks like this. A concave mirror, caved in is the way I remember it, is a convergent mirror. The rays will come together. You will get a real image. You know, when we left class yesterday, the going out party, you saw the flame on the screen. That was, first of all, a convergent lens, a double convex lens, and then with the mirror, it was a convergent mirror, okay, concave mirror. And so you got, sort of gave you the look at it before you learned the physics of it. And that's what's happening. All right. Now, the other kind is divergent. And as you suggest, as you can figure out, the rays never meet. No image. Try as hard as you might. You will never get an image. And for the lens, it looks like this. Double concave. And for the mirror, it looks like this. The light's coming in this way, which is convex mirror. So, in the lens, the light is going to do this, and when it leaves, it's going to do this. And when the light comes into the mirror, it's going to do this. And you can see that these rays here will never meet. just like these two will never meet. That's a divergent lens or a divergent mirror. Is that making sense? That good? All right. So there's not much you can do with those. They're not very helpful. You can't see any image. You can't do much with them. So we're going to do what is helpful. What is, like for glasses, how they used, how we make glasses, okay? So they can converge the lens. Actually, we do some divergence. We push the image further apart. But we'll talk about that later. Okay, right now, we're going to talk about ray diagrams. Physics students delight everywhere. Okay? I'm going to show you how to do it, and then we're going to practice. This is the principal axis. And we're going to say I have a lens right here. Yes, I know it's going to be, it actually looks like this. Okay? In fact, if you want to draw it that way, you can, but you don't have to. You can just draw a perpendicular line, and that represents the lens. Okay? There's a few points along the way we need to note. The first one is F. That stands for focal point. Okay? And then in a lens, we call the next one 2F. And we'll also put it on the other side. F and 2F. And of course, these are exact measurement. Now, if y'all will be real good, children, today we may go outside and find the focal point for a double convex lens. And if we find that focal point, what will happen?
We'll get an image.
The sun. The sun will be focused on that card, and it should burn a hole in it. That's how you find the focal point, is you move the lens until you have the clearest, sharpest circle of the sun on the paper. That's the focal point. Then you measure the distance from the card to the lens. So we're actually going to do a lab while we're out there burning a hole. Okay? We're going to measure that in centimeters. And that is called the focal length.
Is that 2F?
No. Focal length is from here to here. From the lens to F. That's called the focal length.
And what is 2F like?
A 2F is just twice F. It's twice the distance. So something happens on that point. That's the reason we mark it. In Mira, we call that C, or center of curvature. All right. Now, ray diagram. All right. First of all, you put your object, and usually it's represented. Shoot, I don't hear about Rob and all the personal business on here. How do you block? I got it blocked, don't I?
No, you have notifications blocked for your emails.
Oh well. Sorry about that interruption. Okay, this is the object. It could be a pencil, it could be a person, it could be a ball, it could be anything. But you usually just draw an arrow. And the top of the arrow is, of course, the top of the object. Now, we use the term D sub O. That's distance of object, distance from the lens. or object distance, either way. So you measure from here to here. Okay? And the other thing you need to know is from here to here, and we call that hoe.
That's from the top of the object to the bottom.
Yes, sir. Exactly right. That's called the height of the object. Okay, now draw an array diagram will tell you what the image will look like on this side of the lens, because of course the light's passing through, and that little movie screen over here is going to be where the image is. So if we're going to draw a ray diagram, I'm going to use nice different colors here. I'm going to go with a blue. So the first ray does this. It goes parallel to the principal axis, and when it hits the lens, it will bend, right? And it will bend where? Through the focal point every time, out to infinity. That's sometimes called ray 1. There's no particular nomenclature here. It doesn't matter which one you do first. The next one, as you probably have already figured out, is going to go through the focal point on this side and hit the lens. And you see a nice little parallelogram going on here. Where is it going to bend? Just the opposite of the other one. Parallel to the principal axis on the other side. To infinity. Okay? And that's ray 2. Now, once you get really good at this, you can see exactly where the image will be and how tall it'll be. All you have to do is find the intersection of the two rays over here, and let's go with a different color. Let's go with, let's go with this deep blue. There is your image. And as you can see, it's upside down. And you can then get your ruler and you can measure this distance right here. And what do you think you call that?
Distance of image.
Distance of image. Excellent. DI. And then you can measure this to this, and what will that be? Height of image. Okay. Okay, for the purposes of the videotape out there, we're going to now do a problem. We're going to draw it out to scale. I'm not going to put this on the video, but this is what you need to be doing at home, okay? And I'll give you the information.
Mr. Bates, I
Yo.
don't think you ever pressed record.
No, I'm not recording this. He's recording here.
Oh, okay.
He's got me. Thank you, though. All right.
I didn't see that.
That's all right, no problem. Focal length, let's make it 5.0 centimeters. And the height of the object is 2.0 centimeters. And the distance object is 10.